The objective of this lesson is that all students will be able to learn how to add and subtract any rational expression. So before we get into that, let's just kind of back up and let's talk about how to add and subtract just basic fractions. So if I give you 1/2 plus 3/2, since these denominators are already the same, all you would do is add these together and we'll get 4 over 2. The denominator stays the same, which then results into just plain old 2. So it says adding and subtracting fractions with common denominators. So as long as the denominators are the same, we either add or subtract based on what the problem's asking us to do. The numerators only. Leave the denominator the same. Okay? But what happens if I don't have a common denominator? For example, 1/2 plus 3/4. Well, back in the day, your elementary teacher said to get a common denominator. Actually, let's change this to 5. So a common denominator between 2 and 5. 2 and 5 both go into what higher number? They both go into 10. So now we're going to rewrite these fractions as denominators of 10. Okay, so 2 times what will give you 10? Well, 2 times 5. And since we did the denominator by 5, we need to do the numerator by 5, and that gives us a new numerator of 5. And just as a quick result here, if I take 5/10 and I reduce it, will I get this 1/2? Sure. So these are equivalent fractions, it's written in a different form. All right, let's look at the second fraction. How do I go from a denominator of 5 to getting a denominator of 10? Well, I would multiply by 2. So I need to multiply the top by 2, and I get 6. 6/10 is the same as 3/5. But now that my denominators are the same, now I can add these up, and 5 plus 6 is 11 over that 10. So what we need to do when they do not have a common denominator is we need to get a common denominator. We have one too many there. And then we're going to change the numerators and then add or subtract. So now the idea of what we just talked about using numbers only now extends to variables. So these denominators are the same. So we're just going to add these up. So 1x plus 3x will give me 4x. Keep the denominator 10. Now, can I reduce? Yep. I can divide both of these by 2. Because they're monomial over monomial, you can just reduce. Okay? Over here, denominators are the same, so we're going to keep the denominator the same. What we're going to do is we're going to actually do what this numerator is asking us to do, and we're going to take our 3x and add 6. Well, they're not like terms, I really can't add them together like the last problem. But what I can do now is I can factor a 3 out, which will give me x plus 2 over the binomial x minus 4. And since these binomials are not the same, there's nothing else I can do. Put a star next to this one. This is a tricky one. This is a common problem where people will make a mistake and therefore get it wrong. It's saying that we have a common denominator, so let's keep that denominator the same. But it's saying to take 2x, subtract the whole parenthesis here. So you're actually subtracting both parts here. So you really have this 2x from that first fraction, you have a minus 4x, and then you have a minus 1. Which will give you negative 2x minus 1 all over the binomial x plus 3. And if you want to put parentheses around here, that's fine. But that's all you can do. Well, it becomes a little bit more difficult when the denominators are not the same. So what we're going to do when our denominators are not the same, as in before I said get a common denominator, rework the numerators, and then continue on with the problem. Well, it's a little bit more complicated than that. So here's a more detailed list of what you want to do. I'm going to factor each denominator and get the basics. Multiply each piece of the denominators to create a common denominator. So it's going to take you 2 steps just to get a common denominator. Once you get that common denominator, you're going to have to change the numerators. And I can't tell you what to change them to until you actually see the denominator. The denominator drives what the new numerators will become. Step 4 is what we kind of showed in the last few problems. Add the numerators to create one complete fraction. And now this is our new step. We always try to factor the numerator at the end and reduce if possible. So it's kind of like this. You're going to factor the denominator to begin the problem. And then you're going to factor the numerator to end the problem. Let's just start with a real small one. Again, they're not going to be real complex to start with. It's just getting to know the idea. Okay, so 2x, 10x. These are both monomials, so I can't factor anything out. So I have to get a common denominator. So what does 2x and 10x both go into evenly? Well, they'll both become 10x. So we're going to rewrite the denominators with a common denominator. Now, to go from 2x to 10x, I need to multiply by 5, which means I need to multiply this by 5. All right, over here, from 10x to 10x, it didn't change, so my numerator stays the same. Now what I'm going to do is I'm going to combine them for one fraction by taking my numerators and add them together. Well, if I add those together, I'm going to get 2x plus 16, because 15 plus 1 is 16. Now I need to factor the numerator. I can pull out a GCF. Notice that these are monomials, so I can reduce these. Well, 2 goes into 2 once, and 2 goes into 10 5 times. So my real answer is going to be x plus 8 all over 5x. There's nothing else I can do because that's a binomial on top, and this is a monomial on the bottom. That's probably one of the easiest ones we're going to run into. All right, let's look at this one. I can't factor that any more than it already is. So that's a monomial, leave it. But this one I can factor, so let's factor. We can pull out a 4x, and that will leave me with x minus 3. So now what I'm going to do is I'm going to rewrite these. I'm going to look at all my pieces here. So let's look at the monomial first. 4 and 6 both go into what? Well, they both go into 12. So 12 is going to be part of my common denominator. You have an x to the first and an x to the second. So my common denominator will be x to the second. And then we have this binomial here. So we've got to count that binomial as part of our common denominator. Pretty much you got to think of it this way. Your common denominator has to have every piece of each of the denominators all put together. Now, how do I go from the 6x to this common denominator? Well, 6 times what is 12? 2, so I'm going to have to multiply this by 2. X squared times what is x squared? Well, I don't need to change anything there. And notice how this did not have a parenthesis, this binomial parenthesis, and this one does, but since I have to count it, I need to also multiply by x minus 3 in parentheses. So 5 times 2 is 10. 10 times x minus 3 will give me 10x minus 30. Okay, let's look at the next one. We got to figure out how to go from this denominator to this one. So 4 times what will give me 12? 4 times 3. X times what will give me x squared? 4 times x, or sorry, 3 times x. And this parenthesis is here in the denominator, this parenthesis is in the common denominator, so I don't need to change anything to get it from here to here as far as the parentheses go. So if I take x and I times it by 3x, I will get 3x squared. So we've done step 3. Step 4 says now we're going to add these together. Keep your denominator the same. So let's see if there's any like terms here. There's no like terms, so let's just put it in order. We have 3x squared plus 10x minus 30. Now the last step is to try to factor the numerator and see if we can go anywhere from there. Well, it's a magic number, so I'm going to try the magic number. First number times last is negative 90 and adds up to 10. Are there any numbers that multiply to give you negative 90 and add up to 10? Nope. So we tried to factor, it was not possible, so now we're done. Sometimes the numerator factors and sometimes it doesn't. All right, let's look at this one. Step 1 is to factor the denominator to see what we're dealing with. All right, now let's try to get a common denominator. Well, if I look closely, I've got 2x plus 3. So since there's 2 of them in the same denominator, I have to count for 2 of them here. Now over here, I've already accounted for the x plus 3. The x minus 3 hasn't been accounted for, so I need to account for that. So now that's my common denominator. So let's see how my numerators are going to change. All right, so to go from here to here, okay, what's the difference? So take a look at that and take a look at our common denominator. What do we need to account for that's not in the original denominator? Okay, we have this extra x minus 3 binomial. So it means I need to multiply this by x minus 3, which means you need to distribute. And that will give me x squared minus 2x minus 3. Go ahead and distribute and simplify. All right, now how do I go from here to here? Well, x minus 3, okay. X plus 3, x plus 3. Notice that we have an extra x plus 3, so I need to multiply this by x plus 3. But now notice that there's a minus sign, so I'm going to have to distribute here and distribute here. So now we're going to join them for one fraction. You have an x squared here. You have negative 2x minus x, which gives me negative 3x. Negative 3 minus 3, which will give me actually negative 6, over that common denominator. And then we're going to try and factor this here. What numbers will multiply to give me negative 6 and add up to negative 3? Nothing. We tried. That's our final answer.